Welcome to the Geometry Nodes Beginners course. In this video I will give you another example for a curve in combination with instances in the Geometry Nodes editor. For this example I will use a photo I took myself of this fence here, which I want to recreate in the Geometry Nodes editor. So what I basically want to have is a, let's say constant bottom line here, which is the end of the fence or the bottom end of the fence. And at the top we have different heights here. So some of these planks are higher and some are lower, and some, like this for example, are rotated a bit, so they were cut off a bit crooked, or not horizontally perfectly, but a bit like this, a little diagonal. So that's what I want to have, a pretty irregular fence with a bit randomized planks on it. That's what I want to do. So let's start to do this. So at first I want to start with a curve where the fence will be on later, and just, I don't know, move it around here like this and maybe extrude it a bit, so that this will be the path of the fence then, like this. I want this to be the top end of the fence here, so we can put this up around on the same height here, but not that uniformly. So at first, the theory how I want to do this, I want to create a line which is randomly rotated a bit, like this, for example, and then I want to extrude this line downwards, like this for example, and here, and so on. So different rotated lines which are then extruded downwards, and when I have this, I want to extrude them in that direction as well, that I have these three-dimensional planks and so on, you get it? And when we got this, I want to cut them off, or basically scale the bottom part here to the same height, to the same Z value, and then you will have this, and you will have these a bit crooked planks, like this, and they will end up at the same height, and then you can have the fence here. And of course every one of these will be instanced on the points of the curve, and by that you have this fence here. So that's the theory, and now let's do the real thing by opening a new window in the Geometry Nodes editor, create a new group, and now we can start with building the actual tree for this. So at first I want to put a curve to points node. As in the video before, you saw that you can create some points here by this node or with this node, and after that I want to use an instances on points, and for the instance I want to use a mesh line. I can quickly show you the mesh line here. It's basically just a line with a start point, an end point, and points in between, and so on. In this case we only need 2 points, where this is the first and this is the second one, and it should be exactly like this. That's fine. So we want to use this as the instance here, that we have these mesh lines then on my curve here. So now I want to rotate them accordingly to the curve, and as I showed you in the video before, this can be done very conveniently with this rotation output in the rotation input of the instance on points. And here you can see, when I maybe mute all of these, that it's along the shape here. So along the path you have now the curves. It looks a bit weird because the lines here are so long, but that's fine for now. So at first I want to make this a bit larger, like this, that my fence has a bit more length here. So, and then maybe let's just enable that. So that's about what I want to have, maybe a bit larger, and then you can see that the relative size of these mesh lines decreases when I increase the length or the size here of this whole thing in general. And of course you can put this as well in between curve length like before to have this here. So now the curve length adjusts the amount of points. When I increase the length, it will just add more mesh lines. You can see it barely, but they have little gaps in between here. So now we have automatically updating point counts here. So alright, let's continue. Maybe tidy this a little bit up here. Alright, and now we want to continue with a rotate instances. Like I said before, I want to rotate them in their local space, so they're then rotating around this axis here. And I want to, I mean, you could just see it when I just use the X slider here, for example, then you can see how they are rotating. And I want to do this with a random value, so I add a random value node, and I want to use a vector because I only want to do this with one of these values here with one axis. So let's just put everything on 0 for now. And let's say I want to have 0, so negative 0.5 to positive 0.5 on the x-axis. And this I want to use on here. And now you can see that I have these randomized rotation values on my mesh line. And if you don't like this pattern, you can just change the seed, and then you can have another randomization pattern on these rotating values here. But let's just stick with seed 0 and let's continue. Alright, so maybe move this a bit here. Alright, now I want to extrude these values, but in order to do that, I have to realize them at first. So we have to use a realize instances, because now they are real geometry and I can properly process them. So now let's just use an extrude mesh. With this node, you can extrude geometry. In this case, I want to extrude edges. And you can already see what happened. I mean, the angle is wrong, but in general, this is what's doing. You can just extrude certain parts of the geometry. In this case, the offset shouldn't be the normals or whatever, but just the z-axis here. So it's just, it's supposed to go down. And because of that, I will just create my own vector, which has a negative value here. So like this, a negative value on the z-axis, and just use this vector for everything in the same manner. And now you can see my vector now extrudes it exactly along this thing here. So I can basically leave this on 1, for example, and just change the vector. So it doesn't really matter. So this is just the factor, how the length of the vector, and then this is the offset scale. So they're just going to be influencing each other. It doesn't really matter which one you change here. Let's just take this on 1 and use this one here instead. So I think that's okay. And now you can see these extruded little planks here. Alright, so let's continue. After we did that, I want to scale basically these bottom parts here on the same level, on the same z height. And to do that, I have to use a scale elements like this. And with this node, you can just scale certain things. So for example, this would be just everything, but I want to do this only on these parts here. And you can do this by using these selection things. So for example, if I'm extruding something, so let's say, let me just give you an example. Here you have a top and a side. So the original mesh you can view as the bottom basically. So let's say I have here a plane. So this is the base. So let's say this is the base. And when I'm extruding this now, these are the sides. And this too. And this is the top. Like this. So when you're extruding something, the sides are these faces. And the top is basically the same base you just extruded, just on a different place with the sides connecting them. So this is how this selection works. And I want to scale, since, as you see, this edge here is my top now. And what I want to do is I want to scale now my top, which is this edge here at the bottom, at a certain Z height. So what I have to do here is to just select only the top parts, which are these. And if you now look what I'm doing here, it's doing nothing because it's on uniform. So I want to put this on a single axis value, which is the Z axis, like you can see here. And when I change now the center of this Z scaling to the exact vector position here, so this is the center of the scaling, and you can see when I now reduce this to 0, for example, and of course change this to edge, you can now see it. So let me just show you that. So basically this is on 1, this is on how it was before, and when I reduce this, you can see that they get the same level, yeah, because the center is at this vector, which is exactly on this height, and when you scale only these edges here, and you scale them to 0 with this as their center, then they're going to be leveled exactly here. So this is how you can achieve the base at the same level for every of these planks. And now what I want to do is I want to extrude them again so that they get thickness, because for now they are only flat planes basically. So let's just extrude it again. Extrude mesh here. So in this case I want to extrude everything along their normal in that direction. So this is correct basically. So this is fine. But you have to take care a bit, because let's just look at the face orientation. Here you can see what's happening here, because when you extrude faces, the base gets lost here basically. So you don't have the base. Let me just disable that for a second. So you can see they are now hollow basically. You can see it better here. So they are now all hollow here. They have no back. This is normal if you just extruding faces, and what you can do to avoid this or to fix this, you just have to connect this again. So because, as you maybe know, this is your base and this is then the other part. So basically you need this and this at the same time, and you can just do this by joining them, and you can just join them here, and then you can have both. So now you have this base and this extruded part at once, but you have a wrong face orientation here, and you can change that by just flipping it. So there is a flip faces node, and you just put it here, and now you have it, nicely done here. The only thing is they're not connected, because joining just means put them in the same object, basically, these geometries, but they are not connected yet. But that's very easy, how to connect geometry, which basically is almost connected, when it's at the same position. With a merge by distance, you would connect them usually, and you can do this exact same thing here. There is a merge by distance node, and now they are connected, so the edges basically touching here. So this edge and these edges here, they are touching at this point and everywhere else, at the corners. And because of that, you can just use a merge by distance, which means when they are very close, they will just merge into the same point. And because they are at exact the same location, you can use this to really connect them to a common point together. So now it is almost finished. You can, by the way, here just change the height with this vector, for example, how long it should be. And of course, with this extrusion, you can reduce it a bit because it's pretty thick. So you can reduce it to, let's say, I don't know, 0.24 or something. Then this fence is like this, and then you can make it a bit higher like that. And then you can make this whole thing a bit larger. So like this. And now, because you can see that you can now choose with this curve here, the, basically top end of this fence. And the bottom is the same for every one of these. So now you can basically, I mean, maybe I could just turn this off for a second. So you can see now this curve here defines the top end of the fence, and you can now build your fence with just this one curve here, which is pretty nice, like that. And if you want to have more differences on the height, because currently they are only, you have different rotations, but they have the same height for everything, but the rotation is different, but the height is the same. And you can fix this by just moving some of these mesh lines up and down, yeah, before extruding them and so on. So let's just go back before we did that. So we could sneak it in here, for example. Let's just move these parts a bit away and just use a translate instances, which means moving them. And the translation should be on the z-axis, basically. So when I put this on here, oh, sorry, not on the local space, on the global space, so the real z-axis up and down, yeah. So you can move them up and down, and when you want to make this random for everything, yeah, you see that diamond input, which means you can feed it with individual values for every instance. So let's just use a random value node again on vector, and then, for example, you could use here the 0 to 1 on the z-axis, and then you can have multiple different heights. And if you want to increase it, you can see this is now the value for this randomized pattern, how far the range is, basically. So some are translated by 0 units and some are translated by 2.3 units, and a lot of them are in between of these two values. So for example, you can put this very high, let's say on 5, and then you can have this pretty alternating pattern here with this fence. And that's basically how you can build this fence, or these kind of randomized fences or shapes like this. You can just start with instancing mesh lines on a curve like this and then just process them. For example, as I did it now, extruding them and rotating them and so on and translating them randomly. And then you can have these planks basically up and down and so on. And to finish it, you can just, let me just switch to the perspective view. Maybe that's looking a bit better here. So maybe you can just use a bevel at the end, because they are pretty sharp here. Without the bevel, you can see it. So that's not really realistic. I mean, it's alright, but it's not very realistic. You could just give it a bit like this, yeah, a little bit of a bevel around the edges, and then the reflection here looks way more realistic. And by the way, if you want to make them here smooth, because the reflection currently is on these faces here, which is the flat project here of the normals, you can just use a set shade smooth, and then they are shaded smooth really. So, and now you can have your planks like exactly this. And that was the fence building example. It's a bit more complicated than the chain, for example, but yeah, you can see how you can treat your curves and instances that you can achieve things like this, for example. And it's pretty nice. Now you can just extrude your curve wherever you want, and you can have unlimited and perfectly fitting planks around it like this. So this was the example for the fence. I hope you did a good job recreating it and had fun, and of course learned something. That's the most important thing here, what I can deliver. That's all for this video. Thank you, and see you at the next one.